Somewhere out there, sitting in the dark, is a galaxy that shouldn't exist. Not shouldn't exist like it's rare, not shouldn't exist like it's hard to find. I mean, the math doesn't work. If you add up every star inside it, you get more mass than the universe had available at that point in time. That's not a typo. That's not me being dramatic. That's what the scientists who found it are saying. On the record. And the machine that caught it staring back at us is the James Webb Space Telescope, launched on Christmas Day 2021 on top of an Ariane 5 rocket. It took nearly a month just to reach its parking spot, a point in space almost 1 million miles from Earth, where gravity balances out just enough to hold a spacecraft steady without burning fuel. Then came 2 more weeks of unfolding. A sunshield the size of a tennis court, an 18-segment golden mirror, larger than anything ever launched before it. Here's the part most people don't know. That deployment carried 344 single points of failure. 344 individual steps, where if just one thing jammed, snagged, or misfired, the entire 10-year, $9 billion mission would have been over. No astronauts, no repair mission. Webb sits too far away for anyone to reach it. It had to unfold itself perfectly, alone, in the dark, on the first try. It did, all 344. All of that just to do one thing better than any telescope in history: see infrared light. And infrared light is old light, the oldest light there is. When Webb looks far enough, it isn't looking at space. It's looking at time, light that left its source billions of years ago, just now arriving at a mirror built to catch it. Compare that to Hubble, the telescope everyone grew up with. Hubble orbits about 550 kilometers above Earth, close enough to service with astronauts back when the space shuttle still flew. Webb sits nearly 3,000 times farther out, parked at a gravitational balance point called L2, almost 1 million miles away. Too far to fix, too far to visit. Whatever Webb saw out there, it saw alone, and there was no going back to double-check the wiring. So when Webb turned its eye toward the deepest part of the universe, in that first full-color release back in July 2022, it wasn't looking at galaxies as they are. It was looking at galaxies as they were, right after the Big Bang. And almost immediately, something was wrong. The early images were packed. Way more galaxies than anyone expected to see that far back. That part scientists could explain, sort of, but then a handful of them stood out. And not because they were faint or strange looking, because they were huge. Picture landing in a country you've never visited and noticing that the toddlers there weigh as much as teenagers. That's roughly the scale of the problem astronomers were staring at. Galaxies that, by every rule of stellar growth, should have still been infants, showing up already looking middle-aged. In February 2023, astronomer Ivo Labbé and his team published a study in the journal Nature. They'd found 6 galaxies formed within the first 700 million years after the Big Bang, up to 100 times more massive than current theory said was possible. 100 times. Labbé put it simply: add up the stars in those galaxies, and it exceeds the total amount of mass that existed in the universe at that time. Read that again. There wasn't enough matter in existence to build what Webb was looking at, and yet, there it was, sitting in the data, refusing to disappear. So which one's wrong? The galaxy? Or the theory that explains where every galaxy in the universe comes from? Because here's the thing, cosmologists have a model. It's called the Standard Model, Lambda CDM, if you want the technical name. And it's the backbone of basically everything we think we know about how the universe grew up. Here's how it's supposed to work. Dark matter, the invisible stuff that makes up most of the universe's mass, clumps together first, forming a kind of scaffolding stretched out across empty space. Ordinary gas then falls into the scaffolding, pulled in by gravity. Slowly, over hundreds of millions of years, that gas cools, collapses, and ignites into stars. piece by piece, generation by generation. A galaxy isn't built, it's grown. Slowly is the key word. These galaxies didn't have time to be slow. Some researchers, trying to explain the numbers, calculated that these galaxies would have needed to convert nearly every scrap of available gas directly into stars. Almost zero waste, almost perfect efficiency. Real galaxies don't work that way. Nothing in nature is that efficient. And it gets worse. There's a galaxy called ZFUDS 7329. It formed when the universe was just 800 million years old, and it already contains more stars than our entire Milky Way. A galaxy that took our own galaxy billions of years to grow, matched in a fraction of that time by something that had no business being that far along. The study's own authors called it a significant challenge to the standard model of cosmology. Scientists don't say that lightly. Now, before this turns into everything we know is wrong, I have to be straight with you, because that's not exactly what happened next. The first crack in the panic came from an unexpected place, old data from an old telescope. In February 2024, cosmologist Julian Munoz and his colleagues went back through archived Hubble Space Telescope observations of the same patches of sky. Their conclusion, published in Physical Review letters, was blunt. Several of those impossibly massive early galaxies probably have simpler explanations after all. Nothing that requires throwing out the standard model. As Munoz put it, Webb is giving us a new dictionary to translate the language of the early universe. And before we say we need to throw away everything we knew about cosmology, we need to understand that language first. Then came a second study run through NASA's own SEERS survey. That's the Cosmic Evolution Early Release Science Program, led by astronomer Stephen Finkelstein at the University of Texas at Austin. A researcher on that team, Catherine Chorowski, found something important. Some of those monster galaxies weren't as massive as they first appeared. Hidden inside a number of them were overactive black holes, feeding, glowing, pumping out extra light that made the galaxy look far brighter and far bigger than it really was. An optical illusion built out of radiation instead of mirrors, so some of the impossible galaxies got explained. That should be the end of the story, right? Mystery solved, physics intact, everybody go home. Except it isn't. Because even after correcting for the black holes, even after stripping out every galaxy that could be explained away, there are still more massive galaxies out there than the standard model predicts. Chorowski herself said it. We're still seeing more galaxies than expected, just none of them extreme enough on their own to completely break the universe. And cases like ZFUDS 7329, the one that outweighs the Milky Way, formed in a fraction of the time, that one didn't go away. It's still sitting there, unexplained, documented in the same peer-reviewed literature that everything else in this story comes from. So the correction didn't close the case. It filtered it. It separated the galaxies that were tricking us from the ones that are still genuinely defying the rules. And that's the part that should actually worry you. Because for decades, cosmology has worked like a locked box. We had a model. The model predicted what we'd find before we found it. And for the most part, it kept being right. Webb was supposed to confirm that. Instead, in its very first year of operation, it found galaxies old enough, massive enough, and fast-growing enough to put a crack straight through the box. Not shatter it completely. Not yet. But enough that some of the top cosmologists on Earth are now saying out loud, in published research, we might be missing something fundamental about how the first billion years of the universe actually worked. Maybe dark matter behaves differently in the early universe than our models assume, clumping faster, pulling gas in harder than anyone accounted for. Maybe star formation back then was far more violent, far faster, than any simulation accounts for, entire generations of stars igniting in a fraction of the time we assumed was possible. Or maybe, and this is the one nobody likes saying, maybe there's physics happening in that era that we simply don't have a name for yet. Some rule that only applied in those first few 100 million years before the universe cooled down and started playing by the rules we know today. If you want to see how deep this goes, subscribe. Because this isn't the last time Webb is going to break something we thought we understood. Here's what keeps me up at night about this one. Webb has barely started. It's designed to keep running for another decade, maybe longer. Every single deep field image it takes has the potential to find another galaxy like this one. Another object that shouldn't be there, sitting in the data, waiting for someone to notice the math, doesn't add up. So the real question was never, does this one galaxy break physics? The real question is, how many more are already sitting in Webb's archives right now that nobody's looked closely enough to find yet? Somewhere in a folder of raw data on a server nobody's opened in months, there might already be a galaxy stranger than ZFUDS 7329. Older, heavier, more impossible. Waiting for the right astronomer on the right afternoon to notice the numbers don't add up and realize they're looking at something that shouldn't exist, staring right back.